Right, so let's talk about exceptions. Now, what is an exception? An exception is basically an unexpected event in a program. So something that the system, the program cannot handle. So it can be a value that is missing, a null value that is being accessed, something that is impossible to do in a program that causes the system to say, that's it, I cannot proceed anymore. I don't know what to do, so I'm simply going to crash and let the user know that everything has stopped. Okay, so importantly, a system cannot recover from an exception. Okay, you can mitigate that, but if you don't mitigate that, a system will encounter an exception and it will simply stop. Okay, it doesn't know what to do, and the program doesn't do anything by itself. We have to program it ourselves. And if we don't program it to handle the exception, then the system will simply stop. Now, importantly, when execution is stopped, data is lost and the user experience is very bad. So the user will see the program simply stop, crash, burn, and even worse, if we're dealing with something like a backend program that handles data and processes, then a stopped execution is really bad because we might lose some information. So imagine your favorite banking software, a backend banking software that crashes at some point and your transaction is lost. You might have a real problem because you might have a lot of money, so a lot of value in that transaction. And if it just simply crashes and stops, then that can be a big problem. So it causes a bad user experience. So if we're developing applications for users, then a program crashing and kind of restarting from the nearest saved state, then the user might have a bad experience and they might lose data. And we never want that to happen. So here's an example of how you might encounter an exception. So let's say we've done this in the past. Let's say we read something from the console. Okay, so we have this read line instruction. Now, we're trying to convert that information into an int, but what if we don't provide a number and we provide some text? What will happen then? Well, let's go ahead and try it in our code and see what we get. So first we have our read line, and then we're converting it into an int. So I'm going to say var test is read line, and I'm going to try to print out test ? dot to int. Okay, but this time I'm not going to introduce a number. I'm going to introduce some text. So let's see what happens. I'm going to run this. All right, so here we go. I'm going to introduce some text, and then we cannot convert this some text to an integer. So what we get an exception in thread main, which is the main thread here, that says number format exception for input string, because the format of the number is wrong. It doesn't know what to do with this some text information. Okay, so the system is just gonna crash and burn and stop the execution. Okay, so that is exactly what we're trying to avoid. So this is what I introduced, some text, and we get this number format exception. Right, so a little bit more about exceptions. Exceptions always have a message. Okay, so the message for this one would be for input string some text. We will see how to get the message from the exception later on. They have a stack trace. So here we see this is the stack trace. And the stack trace is basically the chain of functions that the system has called before this exception occurred. And we see here that it started at exceptions.kt line 3. So it will tell us where the exception happened, is in line 3 of exceptions.kt, so that we can kind of diagnose where the issue occurred. Then we'll have a parseInt function, then another parseInt function. We can see they are in different locations. We will see later on in the course what functions are, what these classes are, and so on. So don't worry too much about this. It just know that this is a stack trace, and it helps us diagnose the problem because it helps us see where the program went, the trace of each call that the program made in order to arrive at this exception. So that is the stack trace, a log of what the program did before it reached this point, and optionally a cause, what caused this exception to happen. So this is kind of the general structure of exceptions. We will learn, I think in the next video, how to get the exception message, how to get the stack trace, and let the, not the user, but the system administrator know that the exception happened, and let the user know pretty much nothing. They won't see the system crashing. Okay, so this is what we mean by managing exceptions. We will see that in the next video, but for now, just simply know that we can generate exceptions like we did here. And this is the general structure: message, stack trace, and maybe a cause. Okay, so here is a way to manage the exceptions. If we know that a certain part of our code might generate an exception, then we can use something that we call a try-catch block. Okay, so a try-catch block is simply a way to manage exceptions. So here is the general structure. We have our previous example, we have our test read line, and then we're trying to print out this to int. Now, importantly, we have a try and a block of code here. So what this means is we're going to try to execute this block of code. If it works, fine. If it doesn't work and we have an exception, then we have a catch block that catches an exception of type exception. Okay, and here we have another block that says, if you catch this exception, do this. Okay, so we're not going to let the system crash. We're going to catch that exception, and we're going to do some personalized code. Okay, so we try to run a block of code, and if the exception occurs, then we catch that exception, and we will run the code inside the catch block. And then after that, execution can continue whether or not we got the exception. So let's try this out in our code. So first of all, I'm going to say val test equals readline. Okay, now I'm going to try to print out printline test.toInt, and I'm going to use the null operator here. So I'm going to try to do this, and then if an exception happens, I'm going to catch E of type exception, and then I'm going to run some code. I'm just going to simply print line some message, an exception happened. All right, so you might notice that when we use this exception here, okay, the system added this import at the top. Now, what is this import? We will discuss this in more detail in our section about packages and imports. So we will go into more detail, but simply put, this exception is what we call a class, a structure that provides us with some information, and it is part of a structure, a package inside java.lang.exception. Now, don't worry too much about this. I will go into a lot of detail about what packages are, what classes are, and all this kind of information later on in the code. Just for now, it's important that if we use exception, we have to import it because it's not available by default in the language. It's a structure that is based on object-oriented programming. We have that section in our course later on. So it's a class that we can use in our code if we declare it here at the top. If we declare that we import this part of the library, right? So just use this code as it is. The IDE will kindly import this for us, will generate this code for us. It's necessary, but I would say don't focus too much about it. We will go into more detail when we reach that certain part of our course. Right, so we have our exception. An exception happened, and let's go ahead and run this code. All right, so the system is waiting for us to introduce some code. So I'm going to say some text. And here we see that we no longer get the crash. We get an exception happened, okay, which is it tried to convert that information to an int, then it got an exception, and we printed out this message, okay? Here in our example in the slides, I have a message as well. Like I said previously, an exception can have a message. So I'm gonna say, simply put here, dollar expression e dot message. Or actually, it's better to use the localized message, because that gives us the local message in the language of the system where the program is running. Okay, so we're going to use the localized message. And I'm going to put a /n because I want the system to go to a new line. Okay, so this is just going to a new line in a string. All right, so if we run this now, we should get the same thing, but with a exception-specific message. Let's see what that is. All right, some text. And then we get an exception happened. And the message of this exception is for input string some text. Okay, because we introduced some text here, we're trying to convert that into an integer, and that of course doesn't work. But if we run this code and I actually introduce an integer 5, then this code will run and it won't generate an exception. So this catch block is never actually accessed, never run, okay? So this is a very important structure because it allows us to catch whatever exception might occur and allows us to continue the execution of our program whether or not that exception occurred. If we don't use a try-catch block, then the execution will simply stop when the exception is encountered. Okay, so very, very important to catch any exceptions that might occur. All right, so optionally, we can print the stack trace. And the reason why this is a good idea is because when we print the stack trace, this will probably go inside a log, in a log file, and it won't actually impact the user, but it will let any system administrator know that there was a problem that they can later on diagnose. Okay, so it's always a good idea inside a catch block. Okay, here inside a catch block, we should usually say e.print stack trace, because that allows the system to print out that message and not show it to the user. Okay, so let's run this code with the print stack trace here. You can of course put it at the top or below your personalized message. It doesn't really matter. I'm just going to introduce some text, and then here is the stack trace. Okay, now since we're using the console, the print stack trace will go to the console. If we're not running this code in the IDE and we're running it in a server somewhere, this information for the stack trace will go into a log file, and it will wait for the developer to kind of check it out and see what the problem is. Okay, so it's quite important to do that. Normally, it doesn't really matter where you put it, at the top or below. It doesn't really make a difference. It will have the same effect pretty much. So that's pretty much it. That is the try-catch block. Like I said, it's an important part of the code because we always, not always, but we sometimes have unknown situations where we might encounter errors and exceptions, and it's very important to know how we can manage those situations and provide a good user experience for our users. Right, so let's introduce another concept, another part of the try-catch block, which is the finally block. Now, finally block is executed whether or not an exception occurs. Okay, so here is our previous example. We have our test read line. We try to convert that test variable to an integer, and we may or may not get an exception. However, whether we finish this part or we go through this part, this finally block will always be executed. Now, you might ask why we need this finally block. Well, the classic example is, let's say we're using a resource that is very large in memory, right? So think about like a database or something like that. We're actually accessing that. Let's use a database as an example, right? We're accessing a database to get information back and from it and put the information in it. Now, let's say an exception occurs and the execution stops. What will happen is that database reference will remain in memory, okay? Because we haven't freed up that resource, and it will be in memory. And especially if your code is running on a device with limited memory, so for instance a mobile phone, especially at the lower end of mobile phones where you have very limited resources like memory and processing power, if you have this kind of resources that get stuck in memory, your memory will fill up with what we call junk or garbage, and it will eventually either slow down the device or stop it completely, and the user will actually have to restart the device to get everything working again. So it's quite important that whether or not we get exceptions, we free up the resources that we have used in our code. Okay, so this is where the finally block comes in. Even if our exception happens, we will still execute the finally block and we will be able to free up our resources. Now, in this particular example, of course, I'm not using any resources, any large blocks of memory, but we still use it here to exemplify how this works. Okay, so let's go ahead and try it. Let's create our program the way we had it before. Val test equals readline, try to print line test.toInt with a question mark because it can be null. We're going to catch an exception E of type exception. Here we can print line something like an exception has occurred. Okay, and we're going to do e.print stack trace, and then we're going to have a finally block, and we're going to print line something like what do we say here? The execution has completed. Has completed. Okay, so what we're trying to see here is that this code will be executed whether or not we get an exception. So let's run the system, the program, and first we're gonna introduce a actual number that we can convert into an int. So let's say 5. We get 5 and we get the execution has completed. So the finally block has been run, has been executed. And then again, we're going to introduce some text. We're going to get the exception. Okay, an exception has occurred. We're going to get the stack trace. And importantly, this time as well, we execute the finally block. So this is executed whether or not we go through the try or we go through the catch block. Okay, very, very important. So whenever you have resources in your try block that you need to free up after execution is completed, use a finally block to make sure that the required functionality is always performed. So this is the general structure of a try catch finally. I wanted to kind of put it here at the end of this video to show you the general structure that you should use on most of your, whenever you use a try catch, you should probably use a finally as well. So you try, do something, you catch any exception that occurs, and finally you always execute some final part of the code where you release your resources and finish up cleaning your code. So there it is. That is the finally block. Now we have at this point a way to handle pretty much any exception that occurs in our program. As long as we can figure out where that exception occurs, we can use a try catch finally block to manage that issue. So in this video, I want to show you how you can generate your own exception whenever something happens in the program that you as a developer don't like, and you feel that you cannot continue with the execution. So this is sometimes useful if you're developing a library that another developer or other developers are going to use. It's a good way to use a system that's integrated into Kotlin to throw exceptions and block the execution of a certain part of code that is not useful for your execution, for your program, or for your library. So this is a way to generate your own exceptions, right? And of course, you can detect a state in your program that you cannot recover from. You should throw an exception, because that is the standard way for Kotlin to handle this kind of situations. And the keyword that we have here is the throw keyword. Okay, so we can throw an exception to the program that is calling our program. So this might seem a bit complicated, and especially because we haven't discussed functions yet, and we haven't discussed things like object-oriented programming. Of course, we will discuss these things later on, but for now I just want to give you a kind of an overview, how we can use those things, and later on when those other pieces come into place, it will make a lot more sense how we actually use this code. So here is the general structure. We throw a certain type of exception, and we give a message. Okay, so let's go ahead and try that out in our editor. Simply say, let's say we're gonna have a var test equals read line. And then for some reason, let's say we don't like the input that the user has provided, and we're simply gonna throw something like, you can choose whatever you like. If you type here exception, you can choose whatever exception you like. I'm gonna go with illegal state exception. Okay, now importantly, just like previously the default exception, the system has imported the type for us here. Okay, like I've said previously, don't worry too much about the type here. It's simply a way to use this kind of information to add it to our program. And we will discuss more about it when we talk about packages and object-oriented programming. For now, just use it as it is, and hopefully you don't worry too much about this. So we are throwing an illegal state exception, and we put a message, I don't like this input. Okay, so let's go ahead and try to run this. Right, so we're waiting for an input from the user, whatever, just random characters, and then we are throwing an exception called illegal state exception with the message, I don't like this input. So we can see that already we provide the message that we want for the exception. The type of exception is here, and the stack trace is this. It's a very small stack trace because we only use one function call. We will discuss more about that when we talk about functions, but for now we can see where the exception happened in the throw line 5, which is exactly the line where we throw the exception ourselves. So that is basically how you would throw exceptions if you needed to, if you wanted to. I'm guessing you're not going to use this this particular functionality very soon, because it's usually reserved for developers that are working on parts of other systems, and it's used to communicate some problem to another level of the program, right? So some other level of the program that is using your own program. An exception is a way to throw and communicate information kind of upward. So I kind of doubt you're going to use this anytime soon, but it's still important to have it here in case you need it at some point, in case you want to come back to it and and learn about it and see how you can use it. You always have this video here to provide you with this information.